Hey guys, happy Wednesday to you. Today we're going to go over fluid power, or probably the way you're accustomed to hearing it is hydraulics. Hydraulics and pneumatics, actually. This isn't a very long one, so it'll be an easy day for you. What is fluid power? This presentation is taken from the National Fluid Power Association website on what fluid power is. Fluid power is energy transmitted and controlled by means of a pressurized fluid, either liquid or gas. The term fluid applies to both hydraulics and pneumatics. Hydraulics uses pressurized liquid, for example, oil or water, oil being the most common. Pneumatics, though, uses compressed air or other neutral gases. Fluid power can be effectively combined with other technologies through the use of sensors, transducers, and microprocessors. So how does it work? Pascal's law expresses the central concept of fluid power. Pressure exerted by a confined fluid acts undiminished equally in all directions. An example here shows an input force of 10 pounds on a 1 square inch piston develops a pressure of 10 pounds per square inch throughout the entire container. This pressure will allow a 10 square inch piston to support a 100-pound weight equally. Therefore, exerting more pressure, more than 10 pounds, on the smaller side will rise the right side or the larger side up. The advantage. Fluid power systems got many benefits to users, including multiplication and variation of force. Linear or rotary force can be multiplied from a fraction of an ounce to several hundred tons of output. It's easy and accurate to control. You can start, stop, accelerate, decelerate, reverse, or position large forces with great accuracy. And control, multi-function control. A single hydraulic pump or air compressor can provide power and control for numerous machines or machine functions when combined with fluid power manifolds and valves. High horsepower, low weight ratio pneumatics components are compact, they're lightweight. You can hold a 5 horsepower hydraulic motor in the palm of your hand. Low speed torque. Unlike electric motors, air or hydraulic motors can produce large amounts of torque, which is twisting force, while operating at low speeds, and some hydraulic and air motors can even maintain torque at 0 speed without overheating. The constant force or torque, this is a unique fluid power attribute. Safety in hazardous environments. Fluid power can be used in mines, chemical plants, near to explosives. Doesn't have sparks like an electric motor does. And in paint applications, because it's inherently spark-free, and it can tolerate high temperatures. It established standards in engineering. The fluid power industry has established design and performance standards for hydraulics and pneumatic productions through the NFPA line, the National Fluid Power Association, and ANSI, of course, ANSI, which is the American National Standards Institute, along with ISO, the International Organization for Standards. I get it. Then it should be iOS, right? Long before Mac, too. So, the advantages: multiplication, variation of force, easy and accurate to control, multi-function control. One knob can control multiple motors or pistons. High horsepower, low weight, low speed torque. constant force of torque, non-changing, non-variable, safety in hazardous environments, and it has an established standards for engineering, litigation purposes, and so forth. Different applications. Here in this picture here, this John Deere tractor, fluid power is used to transport, excavate, lift materials, as well as control or power mobile equipment. End user industries include construction, agricultural, marine, military, lawnmowers now. Applications include backhoe, graders, tractors, truck brakes, TBCs, truck boom cranes, suspensions, spreaders, highway maintenance vehicles. If it's a work vehicle or if it needs to work, hydraulic can do it. Different applications: backhoes, graders, tractors, truck brakes, suspension, spreaders, highway maintenance equipment. Industrial applications for metalworking equipment, controllers, automation for automated manipulators, material handling. We're talking about maybe conveyor systems and things like that you want to increase, like 1 inch of speed per hour. You can do that hydraulically, where changing gear ratios and chains and cogs for belt drives is just non-reasonable. Here, fluid power is used to provide power transmission and motion controls for the machines of industry. End user industries range from plastics working to paper production. Applications include metalworking, though, all sorts of things. In the aerospace industry, fluid power is used for both commercial and military aircraft, spacecraft, related support equipment. The applications include landing gear, brakes, flight control motors, cargo loading equipment, just to name a very, very few. Fluid power products are sold as individual components or as systems for the original equipment manufacturer, for maintenance and repair and replacement markets. A typical power system that they're showing here, which not a great picture, but it's a hydraulic pump or air compressor, which converts mechanical power to fluid power. A cylinder or motor, valves to control them, filters, regulators, and lubricators. Filters and coolers are crucial to hydraulic power systems, with hydraulic oil being the transfer agent. When it gets hot, it breaks down. Other things are manifolds, hoses, tube fittings, couplings, etc. Sealing devices, O-rings, seals, and so forth. Accumulators and reservoirs, and instruments such as pressure switches, gauges, flow meters, sensors, and transducers. That's a basic fluid power system. I just wanted to go over with this for you guys today. For the rest of the day, I want you to work on your wheels, both your standard wheel and your creative modified wheel. I want you to enter the essential questions and concepts from today in your notebook. Get those answered, write the question and the answer, then send me another link to your engineering notebook, and then get caught up on missing assignments. And check back with me tomorrow. That's all I've got for you today, guys. I will see you tomorrow.